So far, we've talked about two really demand type systems. It's really two ways of looking at consumer demand at the individual level, which is the Marshallian approach, which looks at maximizing utility subject to a budget constraint, and the Hicksian approach that looks at minimizing costs subject to a utility constraint. As we said, there are essentially two ways to look at the same problem. One may seem a little more natural in some circumstances than the other, but because they are two ways of looking at the same problem, you're not limited to using the tool that corresponds to the problem the consumer is solving at the moment, right? Even if I had a consumer that was solving the classic utility maximization problem subject to the budget constraint, I can still look at it as an analyst through the eyes of the Hicksian framework, right? There's nothing about that solution that prevents me from doing that. And for many problems, it turns out the Hicksian framework is going to prove very useful. It has some advantages relative to the Marshallian framework and vice versa. And you'll see throughout the quarter we will use both. And we will use whichever one seems to be the best for solving the problem at hand. That's a very important notion that you want to think about in economics. You're going to have a variety of things in your toolkit, and you want to try to use the one that's the most helpful for the problem you're trying to solve. Sometimes none of them are very helpful, and the problems are very difficult. Sometimes one really makes things very clear that would be very difficult to see the other way. In principle, you could always do it the other way. It just would be a lot harder sometimes. Okay. Now, as I mentioned last time, it's also convenient to know how to go back and forth between the Hicksian and the Marshallian frameworks. And we can really take advantage of, let's say we started with a solution to the consumer's problem. And probably easiest to think about this is a Hicksian problem. So here's some utility level U of x1 and x2 equals some initial utility level U bar. And the consumer chooses some point, x1 star, x2 star. And you said, well, that's this, so x1 star is equal to x1 Hicksian demand system of P1, P2, and U bar. Everybody would agree with that, right? That's the definition of the Hicksian demand system, that x1 star is the quantity demanded according to the Hicksian demand curve when prices are P1 and P2 and utility level is U bar. Now, if I wanted to say, well, what does that correspond to in terms of a Marshallian world, the thing to realize is that this point here would be what? What would the value of that point be? How would I write the mathematical number corresponding to that point? Well, remember, this line represents the minimum cost way of achieving that level of utility, right? That's how we found that line. So the cost level associated with this line must be C of P1, P2, and U bar. But this is not the dollar value, it's how much x1 I could buy, so that's that divided by P1. And this point here is C of P1, P2, U bar divided by P2. Everybody understand that? That is, because that's the minimum cost level, the dollar value of that cost line must correspond to the cost curve C of P1, P2, U bar. Everybody get that? So now let's think about it from a Marshallian world. If I gave you exactly that much income at these same prices, what point would you choose? I'm going to flip it around now. I'm going to give you exactly this much income, which gives you this budget constraint, which implies you're going to maximize utility. Well, that's going to put me right back where I started, right at this point here. So this has to be equal to x1m of P1, P2, C of P1, P2, U bar. All right, that's the correspondence between the two systems. It says the Hicksian amount at a given level of utility is the same as the Marshallian demand curve if I give you exactly enough income to reach that level of utility. Kind of obvious once you see it. It actually took people a long time to figure out how to think about it this way, but it, like most things in life, is much easier when somebody's pointed it out to you. Anyway, this is, I think there's a word for this. I would call this kind of the Slutsky correspondence. This is kind of the Slutsky equation. Everybody heard of the Slutsky equation? I mentioned it last time. This is kind of one level above the Slutsky equation, right? Because Slutsky equation is about derivatives. It's about how are the derivatives of the Hicksian system linked to the derivatives of the Marshallian system. This is a more primitive relationship that talks about the levels. These two functions are equated in the following way. And remember, again, as I talked about last time, this is not an equilibrium condition. This is something that holds no matter what U bar I put in there, no matter what P1 I put in there, no matter what P2 I put in there. This holds for all P1 and P2 and U bars, right? No matter what I had picked, this correspondence is going to work. Everybody understand? This relationship is going to hold in spite, for all P1 and P2. Since it holds for all P1 and P2, I can take derivatives of this thing, and the derivatives on the two sides have to be the same, right? This function, let's fix U bar for the moment, which is a function of P1 and P2, has to be the same as that function. And therefore, the derivatives of this function have to be the same as the derivatives of that function. Okay? So more generally, xih of P1 up to Pn U bar has to be equal to xim of P1 up to Pn C of P1 up to Pn U bar. That's just the generalized version of that. That is, if I had an n good problem, for any one of the goods, that same relationship has to hold. Okay? Everybody follows that? So now if I take the derivative of both sides with respect to a price, I'm going to get partial xih partial pj on this side, because this is just the Hicksian demand curve, so the partial derivatives of that are just the partial derivatives of the Hicksian demand curve, is equal to what? Partial xim partial pj, that's because pj shows up here, plus partial xim partial m, that is the derivative of the Marshallian demand curve with respect to income, times the derivative of the cost function with respect to the price of good j, which is what? What's the derivative of the cost function with respect to the price of good j? It's a quantity of good j. It's the quantity of good j. So this is known as the Slutsky equation. It allows me to go back and forth between the derivatives of the Hicksian system on the one hand and the derivatives of the Marshallian system on the other. Okay, it tells me how utility constant responses to changes in prices are related to income constant changes in prices. And the difference between these two comes from this, what we call in economics, the income effect. And to think about where the income effect comes from, it's pretty easy. Okay, so let me put this over on this side because I think it's the easier way to think about it. So I'm going to write partial xim partial pj equals partial xih partial pj minus xj partial xi partial m. So that's the rewritten version of the Slutsky equation, just moving this over to the other side. And it says, this is what we call the Marshallian effect. Is what we would call the Hicksian effect, which we often call the substitution effect. That is holding income constant. How would this person respond? And this is what we call the income effect. And where does this income effect come from? Well, why does it have the form it does? Can anybody explain where this income effect comes from and why it has the form it does? Yeah.
When the price of a good increases.
Good J, that's the one that's changing here. When price of J goes up by $1.
Even if you wanted to just keep buying the same amount of good J, which is sort of an approximation of your behavior, then you have to spend more of your budget on the same amount of good J, and then there's less left over to buy other goods, so you have to decrease all your other purchases to compensate for the extra income good J.
Yeah, I mean, the way to think about it is this. I'm buying 10 units of good J. The price of good J goes up by $1. I'm effectively, at that point, $10 poorer than I was before. To buy what I bought before would cost $10 more than it used to, right? I got $1 extra on each of the 10 units. Now, I won't necessarily buy the same amount of good J, but I got to buy less of something, right? I can't buy the same amount of everything I used to buy. I got to reduce consumption. And roughly speaking, I'm worse off to the tune of about $10. That's about how much worse I am. Again, the way to think about it is back to where we started the quarter. I'm basically approximating my indifference curve by the budget line. And it says, you know, that loss is roughly a $10 equivalent. We go back to the first day we talked about moving along that budget line. So that's XJ. That's how much I'm losing. Okay? And then it says, well, I'm $10 poorer. How much do I reduce good I every time I'm $10 poorer? This is telling me how responsive good I is to income. So basically, when the price of good J goes up, it's going to have a substitution effect for I. Now, when I say substitution effect, that could either be a complementarity relationship or a substitution relationship, depending on the goods. That's the response I would get holding utility constant, but there's this separate income term. Now, what determines whether this income term is big or small is mostly how important is good J in my budget. If I make $100,000 a year, this $10 change in annual income is really a trivial change in my income, and his income effect's probably going to be very, very small, probably too small to even think about measuring. On the other hand, if I spend 30% of my budget on this good, income effect is going to be pretty big. Right? I've effectively, for every 1% this good goes up in price, I'm going to lose 0.3% in real income if I'm spending 30% of my income on the good. So first thing I always ask about income effects is how important are they? Are they big, small? For some goods, income effects are important. For other goods, they're not so important. Okay? Any questions? Yeah?
So the way to think about this would be to multiply the entire equation by delta T.
If you wanted to put it into like units of change, this is per unit change. So if we multiplied by the change in price, now most commonly we put these in terms of elasticities. So let's put this formula in terms of elasticities. I want to make this elasticity. I put an xi here, right? And I put a pj here, right? That's going to make this into an elasticity because it's going to be the percentage change in quantity over the percentage change in price. That's fortunately what I need over here too, right? So that works out great. Then I'm going to put a pj here, and I need an xi here, and just fortunately enough, I need an m and an m. God was nice to me and made it all work out. And so this is epsilon ij Hicksian equals epsilon ij Marshallian minus the budget share of good J times the income elasticity of demand for good I. That's the elasticity version of the Slutsky equation. It says the percentage response of good I to the price of good J is, I'm sorry, this is Marshallian Hicksian. Sorry, I forgot I flipped my formula around. That's Hicksian. Marshallian response is the Hicksian response minus the share of the good whose price has changed times the income elasticity of the good we're looking at. Okay, so the size of the income effect depends on how big good J is and how responsive to income good I is. Okay. Now, this is where the law of demand, fortunately, can run into some problems, right? Because this implies that epsilon IIM equals epsilon IIH minus SI A to I. Okay? So now if good I is a normal good, remember we already showed that, what's the sign of this term? We know the sign of that term. That's utility constant response to a change in price. Theory tells us that can't be positive. That's got to be negative or zero, right? That is, when the price goes up, you consume less utility constant. That we proved that already by concavity of the cost function. Now, if the good is normal, then this term is positive, this term is positive, and the negative sign is negative. So this whole thing has to be negative. So for a normal good, immediately we know the law of demand is going to hold. That is, the Hicksian demand curve is downward sloping, and the Marshallian demand curve is even more responsive, right? There's an extra term there because the income effect reinforces the substitution effect. Now, you could possibly violate the law of demand for the Marshallian demand curve if you had a good that had a high share and was significantly inferior, and the substitution effect was sufficiently weak. This is a so-called Giffen good case, right? The Giffen good case is very weak substitution effect, so when prices fall, you don't increase your consumption very much from the substitution effect. On the other hand, you spend a lot of your money on it, so when the price falls, you're a lot richer. And at the same time, it's also very inferior, so as you get richer, you want less of it. That could actually cause you to violate the law of demand. It's not easy to find Giffen goods because you need, first of all, a combination of a high share and low income and inferior. Easy to find things that have a high share. Trouble is most of those are normal, so it's not going to help. Now, and people have searched, and they think they might have found it in some places, haven't found it in others, been able to create it in a laboratory with rats. You know, there's all kinds of things you can do to try to get a Giffen good. But I'm not going to spend a lot of time on that because actually most of those searches just prove the theory. That is, if you're going to find one, you got to look for a place where this isn't too big, this is big, and that's negative. That's where you look. And if to the place where you think you can find one, that's where people have tried to look. And they've looked at, you know. Basically, they look at people who are very poor, spend a lot of their income on a kind of food that they don't really like very much, and would love to buy something that tastes better if they could survive and do it. That's a classic place to look for a Giffen good. Not surprisingly, that's what the theory says. That's where you should find them. Any questions that people have?